Right, we're still in arithmetic sequences and series, of which this is a series, and the moment that you tell me that the sum of the terms is, that's what makes it a series then. The question here was, if they tell me what the sum of is, how many terms are there? So first of all, this was arithmetic, in which A is 2 and B is 1. And I know that the sum of is 1, 2, 2, 4. Now I know the sum of formula is or I could have used the second one with the L. The easier one, the quickest one, is the one with L. If you use this one, you must get to the same answer. So A being 2, D being 1, and then I'm finding my N. But it is easier if I use, it's just a little bit quicker. And it's 1, 2, 2, 4. So the N value is the one I'm looking for. The A value was 2. The last value was 49. Equals 1, 2, 2, 4. And I wouldn't mind if you just gave me the answer for this one, but okay. So it's N over 2, 51 equals 1, 2, 2, 4. How do I get to N's answer here?
Divide times both sides.
Divide by 51 times by 2. Which one first? It doesn't matter. Times by 2, divide by 51, and what's the answer, please? So that tells me that there are 48 terms. Now guys, the question says, how many terms will there be if the sum is 1, 2, 2, 4? Couldn't you have just looked at this thing and said there are 48 terms? Are you seeing this?
Yes.
Oh, because now I want to reason this out with you, but now the question was worth 3 or 4 marks. And you just say there are 48 terms. I think they're going to give you the full marks. Although it's quite logical, look at it.
Yeah.
It's only 1 that's not there, and going up to 49, then if it was 1 to 49, it could have been 49, 2 to 49 is 48. So to me, I think it was a silly question for an exam, if they had asked you how many terms there are. Because now physically, if you actually do go and add them up, it has to be 1, 2, 2, 4. Okay, let's have a look at the second one. So D is, no, this was not given like this. The words in the sum was worded saying the constant difference of an arithmetic sequence, because it's very important. I can't say constant difference is of what? Constant second difference, it could have been a quadratic. Okay, we're getting to geometry today. So if the constant difference is D is equal to 4 given, and then they told me in English wording that the 8th term is equal to 8. What do I then write for the 8th term?
7D.
Excellent. What are we doing all the time? Tn is A plus n minus 1 D. Then we substitute our A. No, not our A. That's the question. We've got D. We don't have A. To solve then for A would be equal to, this is 28 minus 28, so A is equal to negative 20. First one, check. I've done A. The second part of this question though was, find the number of terms for which this sequence will be a sum of 0. The sum of 0. Can that even possibly be true? Now they never said so. But could you go and write down the sequence now? Once you know what A is, and you knew what D was from the start. What does the sequence look like? You start at negative 20. Then it's
16.
negative 16 because you're adding D for all the time.
Negative 12.
Negative 12.
Negative 8. Negative 4. 0.
And then?
4. 8.
Okay, I'm writing it for a purpose. Are you with me? What's this wacko stuff? You would have said plus 4, 8, etc. So can you see how it can add up to then to 0?
Oh, yeah.
Can you see it? And now I can even go count and say there were 5, should be 11. because it wasn't so many terms and you did that, you should have gotten all of your marks if you did that. Okay? But now, say for instance it was 100 terms that would give you the sum that's equal to 0. Then you couldn't count to there. I'm just showing you that the logic behind it is there. Now if I want the sum of the n to be 0, I want to know how many terms must I get to have the sum being equal to 0. Can I now again use the formula with the last term? No, because you don't have it. You've got to use the n minus 1 d1 equal to 0. I'm trying to find out which n it must be. If the a is negative 20 and the d is 4, but the answer must be 0 because they want the sum to be equal to 0. Now, again, all the variations of techniques of what you're going to do. This will give me minus 40, right? This will give me plus 4n minus 4. Just let's do it that way for now. This, I can time away the 2 and get
0.
Still 0. Okay? But I can't time away or divide away the n because you could never divide away by a variable because it might be 0. So if I now simplify this, let's just take a shortcut. This would be negative 44, right?
Yes.
Times with the n, or let's just say, times with the n. Let's go quicker. So it's negative 44n. And then this would have been 4n times n is 4n squared equal to 0. Answer. What do I do now?
I took out an 8.
Take the negative 44 over and
Divided by 4 and 8.
divide by n. Can't.
I took an
So you
8.
have to factorize. Now if you want to make two brackets because we've got this fantastic calculator, our a value would be 4, our b value would be, and our c is 0. Can you do that?
Yes.
Yep. Answer would be x on the calculator would have told you that it would be 0. Well, I think it was 11 first, if I can remember correctly, if I did it on the calculator. Or n is equal to 0. But now crooked, right? So this should be n minus 11, right? And then n minus or plus 0 if you really want to. It's not wrong. But actually what you should have done is said, what type of factorization is this? You take out a common, which is what?
N.
4n. And what's left is n minus 11. So you got n is equal to 0, n is equal to 11. Now they are going to have a problem with you having this. Because where did the 4 go? You should have shown them that you must first divide by a 4, which we did here by taking out the common 4. Then there's no problem. So be careful to do the shortcut and not give them everything. So if you wanted to go and use your a and your b and your c, first divide by 4. Then you would have gotten n squared minus 11 n. Then nobody would have had a problem with you saying n minus 11, n minus 0. You guys still that, they won't deduct a mark for it, but actually you're taking out one n. And there's your other bracket. This is the way we used to always do it. Divide by 4, take away the 4, or it can be there, doesn't matter, so n is 0 or n is 11. Am I done with my sum? Giving them this as an answer. N cannot be 0, why? What does it mean? The sum of no terms will obviously give you nothing. It's true, but obviously that's the one that's not applicable. I'm going to add 11 of them together to get to 0. Got it? Right, number 6, I want to read with you when we put it on the board. It says that the sum of the first 14 terms of an arithmetic sequence is 4, 3, 4. So the sum of the first 14 terms is, how do I write that? The sum of the first 14 is equal to 4, 3, 4. Then they say the sum of the second and the 8th term is 42. The sum of the second and the 8th term.
2, 8 plus 2, 2.
not this. The moment we hear the sum of, we want to write is. The sum of the first term, that's also sum of, right? Sorry, not the first term, the second term and the
Eighth term.
let me get the right sum here. Second and the eighth term is equal to 42. Writing it into math language. The sum of the second and the eighth term. You know that you wanted to write S. You felt it. You wanted to write S. But you cannot. Here's a formula for sum of 14. There's a formula for term 2. There's a formula for term 8. So tell me please, what is the formula then for S14? And how come I go for arithmetic? Because it's all you know at the moment. You're going to know geometric just now. But I have to tell you that it's arithmetic, otherwise it could have just as well been geometric. So then I've got 2a plus n minus 1.
13D.
Ah, excellent. And then this n would have been?
14.
Okay, please be careful. N is n. But n minus 1 is then 14. So we're solving for what? A and D. I can simplify a little bit here. I can do what? 2a plus 13d equal to, let's take this 7 and divide it there. Please give an answer.
62.
Are you sure? Okay. And then for this one, what are the formulas that I'm using? For terms. The formula is a plus 1d. Do I need to write the 1? And for term 8? A plus, do you see it? Term formula. Term formula. So when we add, we get 2a plus 8d
Equals 42.
equals 42. Is everybody with me that I've got simultaneous equations? I'm stopping there because I want to show and remind you of something. These simultaneous equations can be done with elimination. Do you still remember way back in grade 10? You were taught specifically in linear simultaneous equations that there is a technique called elimination. What do we normally use? Substitution. So for substitution, you could get this a alone quickly by dividing the whole thing by 2. Get the a alone, substitute it back in there, and it's perfect. I'd like to remind you with another technique. When the two coefficients of either the a or the d is the same, elimination is a very good idea. So I'm going to call this number 1 and this one number 2 and remind you that elimination works this way. So when we want to add or subtract, it's either going to be add or subtract those two. So that either the a or the d is eliminated. How will I eliminate the 2a and the 2a? I have to subtract them. If this had been minus 2a, you would have added them. Then it would have been eliminated. Because now, and also, it has to be the a, then the d, then the equal, then the number. A, then the d, then the equal, then the number. Can you think back 2 years ago? Then when you do say 2a minus 2a, it's eliminated, it's gone. 13d minus 8d is going to give you
9.
Then comes the equal sign. Then the 62 minus the 42 gives you, and you're solving for d, so it's equal to, quick. If you had gotten the a alone, substituted it back in, did you also get d equal to 4?
Yes.
You should have. You should have. Different technique, and the technique is called? Now, sometimes it's a nice tool to be able to use, but if you don't know it, you can't use it. And it's actually very quick in this case. Right. Once I have the d, I'm not done. I still got to go back to which one? Doesn't matter. 2a plus 13d is equal to 62. Help me quickly with these numbers. So that'll be 42. You're not helping me, guys. 2a is equal to 20 and a is equal to?
52.
So again, is
52.
this 52? Thank you. And this answer then would be
10.
10, and the answer would be? What was the question? Find for me the first term and the constant difference. The first term, there it is. If you want to write this is the first term, it's fine, but everybody knows A is the first term. And the constant difference, so I'm highlighting. There's my answer. There's my answer. I'm done. Can I still go and write down the sequence that they were talking about? Yes, but not in an exam. You don't have time. But what would this sequence? Well, it's actually a series, right? If I say sum of, who cares? Let's write the series or the sequence. Would start at 5. Then
9.
we're adding 4, so it's 9. 13. 21. Why do I want to go on and on and on? Because I want to show you something. That 2, 4, 6, 7. Another one, please. Okay, so this is term 2. And there's 3, 4, 5, 6, 7, 8. Add them together.
42.
It does give me 42. You don't have time to check everything out, but you keep working. No one said get me the sequence. No one said check it. And I'm definitely not going to go for the sum, so 14's one, and say plus, 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 and check if the sum of 14 is equal to 4, 3, 4. It's just, for now, we're just satisfied that we're on track. Okay. Right, number 12 says, Henry has an income of 60,000 and it increases yearly with 4,000 rand. His expenses is 35,000 rand a year, and that increases every year with 1,500 per year. How many years will it take him to save 150,000? This sounds like finance. So what's it got to do with sequences and series? Are you with me? We're getting to an application. First of all, they said to me, his income was 60,000 and every year it goes up with 4,000. So his income would look something like this. 60,000, then the next year, 64,000, then the next year, 8,000. I think we've got the pattern. His expenses were 35,000, and then it goes up with 1,500. This is in not real life, I think, and 38,000, and etc. But they want to know how long will it take him to save 150,000. So I need to know what he is saving. So in the first year he's saving. Do you agree? They never said so. So this is not a level 1 straightforward sum. It's not high level, but it's a little bit different application. This year he's saving 20.
7,500.
And then they're saving. Are you seeing a pattern here? In the saving, because what are they asking me? When will he save a total of? So I'm looking for the SN must be a total of 150,000 of this thing. I'm going to go for those two. I'm going to go for this, the saving. Because after the first year he had 25,000, then he adds that, so it's 52,500 after 2 years, etc. And I'm trying to save 150,000. So now the A was equal to 25,000, and the D 2,500. So it's the same type of sum, it's just large numbers. So we're going to go for SN. Can we use the one with the last term? No, because you don't have it. Okay. Firstly, can I get rid of this 2? Have you seen me doing that all the time? Because I don't want fractions. So let's keep the N and then let's make that one 300,000. Technique. Whether you want to do it or not, later somehow you're going to have to work with it. 2 times A. The A was 25,000. N minus 1, I still don't know what N is, and D is 2,500. And we are solving. So this would be 50,000 plus 25,000, 2,500 in minus 2,500. I'm doing it the other way now. At 300,000. Just large numbers. That's all that it is. Adding them together, this would give me 47,500. Am I right?
Yes.
Times with the n just to save some time. And then this 2,500 to n times n is 2,500 n squared. Bringing that 300,000 across, I still got it equal to 0. Correct me if I get something wrong. Hopefully, I think so. We're going to be able to divide everything by 25,500. Please give me an answer for the middle one. I think it's 49, I can't remember. How much is this? 4,7,500 divided by 2,500.
19.
Thank you. And the 300,000 divided by 2,500.
120.
Thank you. Okay, large numbers, but it still says the same maths. How would I do this? Please use either your factorizing skills or your old calculator with a formula, or please start with the new formula. What are the answers, please? Quick.
X1 is 5. I mean, N 5. Negative 24.
Negative 24. Am I happy with this answer? No, I need the factors. N minus 5 and N plus 24. That's how the calculator helps me to cook it right. Still I'm not finished. Because I have to say,
Not applicable.
not that one. Whether I say not applicable or scratch it out, I've got to choose and show them that I selected this one and not that one. Is it possible that it could have been 5, 5? Say I asked you how long will it take him to save 160,000. It would have been 5, something years. So a little bit longer than 5 years. Are you with me here? This particular sum could have been something like that. 5, something years meant a little longer than 5 years. I would have taken to get to 160,000. Are you with me? That's the end of those series. Tomorrow we'll look at geometric sequences.